Okay, here we go. You have Unit 7.3 notes. So what we did on the Friday, raise your hand if you were not here Friday before break. Anybody? Okay, that's going to be without a doubt, a lesson that you have to figure out. The problem is that the video didn't make it. So you're going to have to look at videos for previous years. So video didn't make it. So video, I accidentally pressed cancel instead of save. So. Fortunately, you have 6 previous years of videos that you can watch. It shouldn't be a big deal. You just use that search button on the interweb. Because people come to class, they weren't here the previous weekend, and so they're used to just following exactly what we do in class. So one year I might get through one more example or one less example, and they want to see exactly what we did, and they just go to the page and they just click the newest video as opposed to looking through old ones. So, all right, here we go. So we got these double angle formulas. You remember the sum and difference formulas, which are sitting right up here. Over break, that's one thing I did is I proved the sum and difference formula. It's kind of tricky to do. We'll give you guys an opportunity to do that sometime if you want. But if I were to have a plus a, what's a plus a? 2a. Which is what we have, a double angle. And so if you were to have the same angle here, a plus a, this would come out to be 2 times the sine of a times the cosine of a. So we turn it from a double angle into a single angle. And that's helpful for us. If it's cosine, you have 3 different formulas. You can either use cosine squared of a minus sine squared of a. Or if you don't like that one, you can use 2 cosine squared of a minus 1. Or if you don't like that one, you can use 1 minus 2 sine squared of a, which is the one I choose to use all the time. Inevitably on the test, there will be a number of people who write down all 3 of these, which is completely redundant. You just need to choose one. But people are so confused, they don't know what to do, and they don't want to write IDK because they know how much I hate that. They just start writing down 3 formulas, and yeah, whatever. Okay, so tangent of a double angle, you get tangent square, or excuse me, sorry about that. Get that 2 tangent of a divided by 1 minus tangent squared of a. That is a formula I've really never used in my life. What I use instead is I use sine of 2x divided by cosine of 2x. You'll see. Okay, lots of questions floating out there. Right. Okay, so let me try to deal with each example. First of all, Carter and Lauren, you guys won't understand because you weren't here on Friday, so you won't understand this piece. But if you have, say, the sine of 15 degrees, folks, remember how we wrote that using a difference? Sine of 45 minus 30, right? And we used a formula. We got sine of 45 times a cosine of 30 minus the sine of 30 times the cosine of 45. And so therefore, we were able to come up with an exact value of sine of 15 degrees. Okay? And so that was the formula that we used. So the deal is that now what we're saying is that get rid of the 45. Let's say you have angle A plus angle A. Well, then that becomes the sine of angle A times the cosine of angle A plus the sine of angle A times the cosine of angle A. What do you notice about these things? They are the same. So you get 2 times the sine of A times the cosine of A, which is exactly what our formula says right here. Okay. Now, I could prove every single one for you, but that would take us a lot of time. So what I'm going to do is, like, for example, here, if you wanted to get rid of the sine squared and put in 1 minus cosine squared, you would get the formula below you. And you put in 1 minus sine squared for the cosine squared, you get the formula at the bottom. Okay, there's very basic substitutions we can do to come up with these type of formulas. This one may seem surprising to you. First hour thought I was a wizard for coming up with it, and I'm going to suggest to you that this is not too difficult to think about, right? We know that tangent is sine divided by cosine. So sine of 2x divided by cosine 2x is tangent of 2x. That's all it is. So wizard, yes, thank you. I'm a genius. I should have written A. So. Okay, so here's the problem you get on the test, and people write IDK, and you become overconfident, and you put your homework off to the end, and that's where you start crying, and then you have your parents call on the day of the test and excuse you because you were putz and weren't ready on time. So that's generally how this goes. So I have cosecant of x is equal to 2, and it wants to know not sine of x, but sine of 2x. And it wants to know cosine of 2x and tangent of 2x. Well, I'm going to just start by writing down the formula. Sine of 2x is equal to 2 times the sine of x times the cosine of x. It's very helpful in calculus when we can go from a double angle formula down to a single angle formula, or the other way. Okay? So again, you're in pre-calculus. The whole idea is not to teach you stuff that you're going to use tomorrow. The whole idea is to teach you stuff so you can do calculus. Calculus is the most powerful tool the world has ever known. But we don't know how to use it yet because we're very limited in our trigonometry skills. Do we use this in calculus? Yes. So let's go to work. It would be nice to know sine of x. What's sine of x? A half. So already I have 2 times 1/2. Well, that wasn't too tough, was it? Now do you understand why I get upset when people write IDK for this problem? So all I have to do now is figure out cosine of x. How'd you get the root of 3 over 2? Yep. So that's all you have to do. We've done that 15 times this year. Sine squared plus cosine squared is 1. Square sine, what's 1/2 squared? 1/4 or 0.25 plus cosine squared is equal to 4 over 4. Now what? Subtract the 4th. Cosine squared of x is equal to 3/4. Square root both sides. Cosine of x is equal to positive or negative root of 3 divided by 2. Is it positive or is it negative? Why is it negative? Because you're in the second quadrant. And cosine is negative in the second quadrant. Well, that was pretty nice. Now all I have to do is just multiply that, and that will tell me what sine of 2x is. 2 times 1/2 is 1 times that is negative root of 3 over 2. You get to choose which of the 3 you want to use for cosine of 2x. I'm going to choose to use 1 minus 2 sine squared because it's a free country. I can do whatever I want. So 1 minus 2 times, what is sine squared? 1/4. Sine is 1/2, so sine squared is 1/4. 2 times 1/4, 1/2, and 1 minus 1/2 is 1/2. Now, tangent of 2x, so this gets to Rachel's point. Rachel is wondering, well, Mr. Gentz, why wouldn't you just use the formula that the book gave you? Looks really complicated to me. First of all, I'd have to figure out tangent of x, and that would require me to take sine divided by cosine, right? Well, let's just do sine divided by cosine for this part, okay? The formula is, it looks like some of it got erased. I take sine of 2x divided by cosine of 2x. So what is sine of 2x? Negative root of 3 over 2. Right there. Divided by 1/2. I get negative root of 3. Ask. And I will show you now. Okay? I will show you. Okay, so let's understand exactly where the question is going. In this one, I can actually figure out x. I know that x is actually 150 degrees. I've worked the problem through. I know that that's my angle. You won't always know that. It could be, say, 37 degrees. It could be 172 degrees. In this situation, I know that x is 150 degrees. If you double 150, what do you get? So look at what you have, okay? Let's make this connection, okay? X is 150. 2x is 300. So you figured out that the sine of 300 is this. The cosine of 300 is that. The tangent of 300 is that. They didn't tell you it was 300 ahead of time. Okay? Now, let's just make some sense here. It says it's in the second quadrant, but it says sine is negative. Is sine positive or negative in the second quadrant? Sine is positive, so why do I get a negative result? Because you're doubling it. This is not talking about 150 degrees, which is in the second quadrant. This is talking about 300 degrees, which is in the fourth quadrant. Is sine positive or negative in the fourth? Negative. Positive or negative in the fourth? Cosine? Positive. How about tangent? Boom. All right, we move on. Half angle formulas, and we can be done. Suppose you want to find half of an angle. So, for example, cosine of 15 is the same as cosine of 30 over 2, right? That's 15 is half of 30. Well, we have a way of finding formulas for that. And again, I'm not going to show you how we derive each one. You just have to trust me. If you want to see it, then let me know, and we can sit down sometime. I don't know, like say 6:45 in the morning. I'll show you how it works out. Okay, but that's probably the only time we got. So we got cosine 30 over 2. If you want to find sine of x over 2, that's equal to plus or minus the square root of 1 minus the cosine of x divided by 2. The cosine formula is very similar. Cosine of x over 2, or a half angle, so instead of a double angle, we're doing a half angle, is plus or minus the square root of 1 plus the cosine of x, all divided by 2. For tangent, you get two formulas, and you get to choose which one you want. So the tangent of x divided by 2 is equal to 1 minus the cosine of x divided by sine of x. Or you could use sine of x over 1 plus cosine of x. True or false? You have to memorize all these formulas for the test. False. I have put together for you a master sheet of all these formulas. Thank you very much, Mr. Gans. Oh, no problem. I just like to help my students. So you can see the double angle formulas. We've just gone over those. Now we're moving into the half angle formula section. Do not look at your notes when you're doing these problems. Look at this sheet, because this is a sheet you get to use on the test. Sometimes people say, well, I didn't know where to go on the sheet. Well, that's your fault. You should have been using the sheet, not your notes. Okay? I'm trying to show you exactly what you're going to need to do. So we go back here. Half angle. What angle do you take a half of to get 15? 30. So you can see that our angle that we're dealing with is going to be 30. And it's plus or minus, if I follow the formula, square root of 1 minus or plus, then what? Cosine of 30. What number do you think people put there? They put 15. You don't put the number there that's here. You don't put 15. You put whatever you take half of. Yes. According to the formula, cosine plus, sine minus, divided by dos, Spanish for 2. So we need to do cosine of 30 degrees. But first of all, let's do the plus or the minus. Which quadrant are we in if we're 15 degrees? First quadrant, so it's going to be positive or negative. Positive. Well, we figured that out. 1 plus cosine of 30. Who knows the exact value for cosine of 30? 5/6 is the radian measurement. What's the exact value of cosine of 30? Root of 3 over 2. So if you didn't know that, that was on your final exam. You had to make the 30-degree angle, find that location, root of 3 over 2, and 1/2. Cosine is the x value, so we have the root of 3 divided by 2, and that's all over 2. Okay? If you don't know how to do that yet, we got to figure that out because you're going to have to use it during this entire unit and afterwards. So, I got a complex fraction. What should I do? CD. Come on, denominators. All right, there we go. So, I changed 1 to 2 over 2. And I got the square root of 2 plus the root of 3 over 2. So that's the top. Divided by 2 over 1. Now what? Multiply by the reciprocal. All over 4. Can you take the square root of the bottom? Yes. Can you take the square root of the top? So we have the square root of 2 plus the root of 3 all over 2. So that's a new option for you. You've never seen a complex radical before. But a radical in a radical, there's nothing you can do about it. It's just the way it is. And if you're anything like me, if you're anything like me, you want to check your answer. And so you take the cosine of 15, and you come up with 0.9659, which sometimes people write down as an answer for this problem test, which I award 0 points for. I check my answer by doing the square root of 2 plus the square root of 3 divided by 2, and I get what? Exact value. Lauren's impressed. All right, last example, sine of pi over 8. What do you want to do first? Okay, TJ wants to leave it alone. He's got the give up motto. Let's give up. Okay, so you're going to convert it into degrees. 22.5, because pi over 4 is 45, and pi over 8 would be half of that, so 22.5 degrees. So, notice that in this problem, cosine of 15, instead of doing the half angle, you could have done cosine of 45 minus 30. You could have used our sum and difference formula for Friday, which Lauren and Carter still need to learn. Okay? All right. But what I have here, you can't do a sum and difference formula for sine of 22.5, can you? No, you can't. So we're going to do a half angle formula. What do you take half of to get 22.5? So this is sine of 45 divided by 2. Well, I've got a formula. It's plus or minus square root of 1 minus the cosine of angle A. What's the angle? 45 divided by 2. 22.5. Which quadrant are we in? First quadrant. So is it positive or negative? Positive. So I get square root of 1 minus root of 2 over 2. Very good. No, it shouldn't. Let's look at our formula. Formula says half angle formula for sine is 1 minus cosine over 2. Okay, so cosine of 45 is the root of 2 over 2 divided by 2. Oh no, what do I do? Very good. 2 minus the root of 2 over 2, all over 2 over 1. Now what? Multiply by the reciprocal. So times 1 over 2. And I get square root of 2 minus the root of 2 all over 4. Can you take square root of the top? No, can you take square root of the bottom? Yeah, so I get 2 minus the root of 2. That in the square root divided by 2. So that's my answer there. Okay. That's okay. We could choose what we like. Now, look at what you just did. You got 45, and you divide it in half, and you got 22.5. Okay? Watch what happens. Yeah, they were wizards, yes. We bow to them. All right, here you go. So, today, this is your assignment. If you were not here on Friday, that was Friday's assignment. There you go. I'll have it posted online just like I do every day.